Today we'll talk about factoring using special patterns. So what exactly does this mean? What's a special pattern? Is this something new? Well, the answer should be no. Way back when, we worked with a pattern, and it was called a difference of squares. Try to write this out for you. Difference of squares. It was a special pattern. And what we said is that if we understood the pattern, we could just go ahead and look right at the problem and figure out what to do. So for example, if we saw something like 4x squared minus 9, and it was equal to 0, and we wanted to solve this by factoring, we could take the 4x squared minus 9 and say, hey, 4x squared is really 2x times 2x, and 9 is really 3 times 3. That means they're both squares, and the minus sign means that this is a difference. In other words, difference means a subtraction. So what we did at that time is we would rewrite this as 2x minus 3 times 2x plus 3. And recognizing that you can go from this to these two guys, that's called factoring using a special pattern. In this case, it was difference of squares. Today we're going to talk about a new special pattern, and it's called, well, we'll actually have a couple of them. This first one is called difference of cubes. Let's start with that. Difference of cubes. Ooh, sounds exotic, yes? All right, so we're going to start off with one that's a little bit tricky. It's going to be, let's try 16 x to the fourth minus 54 xy. And we won't solve. All we're going to do is factor. If we have an equal sign, then we have to actually solve. And by the way, I did not finish this problem, but over here we're simply going to factor. I want to demonstrate this concept to you. Okay, so the next step is we're going to first, before we do anything else when factoring, we always factor the GCF first. So I'm going to take out, in this 16 and this 54, there's at least a GCF of 2. So I'm going to take that out. And then there's an x to the fourth here and an x here. So I'm going to go ahead and take one x out because I can do that from both of these guys. And now I've pretty much factored out my GCF. So I'm left with 8x cubed and minus 27y. Now, I knew there was something strange here. I meant to make that a y cubed. This thing is not going to be a really good example without it. Okay, so now we've got 8x cubed minus 27y cubed, and it turns out this guy is a difference of cubes. So let's see, maybe you can't see it, so let me try to rewrite it in another way. Again, we still have the 2x, but 8x cubed is the same as 2x in parentheses cubed. And 27y cubed is the same as 3y in parentheses cubed. And so now we have two things that are cubed. And now I'm going to show you the special pattern. The special pattern goes like this. It's a cubed minus b cubed equals a bunch of stuff. There's the stuff. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Now, this is something that I don't know that you need to memorize, but you need to know how to use it big time. And one of the things hopefully we'll try to do in class together is we're going to try to multiply a minus b times these three things and see if we actually do get that, because that is the goal. One of the things I want you to notice is that the reason we're using this special pattern is because this stuff here, these are the factors of this thing over here. Okay, and if we were able to factor a squared plus ab plus b squared, then we would have just included that in the formula here. The reason why a squared plus ab plus b squared is not factored is because it's not factorable. And so what ends up happening is when we factor using difference of cubes, the only way to get a solution with this guy, if we have to solve, is to use quadratic formula. Over here, it's easy to get the solution with the a minus b, but this guy, we'll have to use quadratic formula if we want to solve. Now, for this problem, we're not solving, we're just factoring. So, let me get back to business here. So what we'll do is we'll say this. We've now got 2x, and what I'm going to do is I'm going to follow the pattern. It says here that, by the way, let's label this stuff so you guys can see what's going on. I'm going to consider this 2x to be a, and I'm going to consider this 3y to be b. And now I'll go ahead and just fill in the formula here. So what the formula says, it says take a, so we say that's 2x, and then subtract b, so b is 3y, so minus 3y, and then multiply that times a squared. That's, again, a is 2x, so a squared would be 4x squared. People commonly make the mistake here. They might square the 4 and forget to square the x. It's just a very common mistake. A times b is 2x times 3y, so we do plus, that'll be 6xy, and then b squared is 3y squared. Not negative 3y, but just 3y squared, so plus 9y squared. And again, it's an easy mistake not to square the 3 and the y. You've got to square both. Again, just to make it real obvious for you, it's 3y squared, which is the same as 3y times 3y, which gets you 9y squared. Just want to make sure you guys are with me on that. Okay, now this is factored as completely as we possibly can, and that was the goal for this example, so yay. So that is factoring a difference of cubes. Now, it turns out that we can also factor a sum of cubes, so we're going to take a look at that as well.